get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, Bismillahirrahmanirrahim. Hello there everyone. Assalamualaikum and a very good afternoon. Okay, welcome to Pusat Tuisyen AYU, a joint venture with eDidik Malaysia and Kelab Guru Malaysia. #bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our season with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please recite your prayer according to your religion. Okay, amin, 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 ya Rabbal Alamin. Okay, how is everyone doing today? My prayer that everyone is doing fine and ready to proceed with today's classes. Okay, I'm Teacher Su, your moderator for today. And together with me, our control host, Madam Rosmaya from SMJKC Yuhua Kajar, Selangor. Our observer, Cikgu Hafsah Ayu, Muhammad Arifin from SMK Sultan Sulaiman, Kuala Terengganu. And our important person of the day, our presenter, Cikgu Nun binti Muhammad Noh from Matriculation Kuala Pilah, Negeri Sembilan. Okay, for the record, we are now live on Cikgu Nun channel. So as a sign of support to Cikgu Nun for her hard work in preparing to the lesson, please subscribe her channel, not forgetting ours too. Okay, as usual, the lesson will last approximately for 1 hour. And please follow the class up until the end and give your full cooperation in making this season a lively one. Okay, please take note that the certificate link will be given at the end of this season. Besides this, don't forget to claim your credit for today's live class. Okay, collect the credit to redeem the attractive price in store. The link to claim the credit and the presenter username will also be given at the end of this season. However, please be alert as the 1 letter and 5-digit code to be given at the end of the season. So get ready with your pen and paper. I would also like to remind students to use appropriate language and also use appropriate profile picture. If possible, use your own picture. If you wish to post comment on the chat board. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. Okay, students, stay focused, and if you have any question, please write on the chat board and Cikgu Nun will try to provide you with the answer. So before I proceed to our lesson, let teacher announce the first code. Okay, the first code is A1. The letter is A and the digit is 1. So now, please welcome Cikgu Nun.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. And hi everyone, how are you? So see you in this free tuition class from Academy YouTuber. So my name is Madam Nun binti Muhammad Nun. You can call me Madam Nun. I am from College Matrikulasi Negeri Sembilan. Okay, so thank you Teacher Su as our moderator. So before we proceed to our tuition class today, to our discussion, so I want to introduce you first our team, which is here is the physics teams, which is led by Madam Rosmaya, and we have Teacher Su, our moderator today, Teacher Hafsah Ayu, myself, and also Teacher Suhaya. We also have mathematic teams. Okay, so for the mathematic teams, we are lead by Teacher Im and with the Teacher Zainariah and Teacher Eileen. So instead of a mathematic team, we also have the biology team, which is led by Cikgu Faiza. And then we have chemistry team led by Cikgu Shahnun. And you also can join our Perakaunan and Economy team, which is led by Madam Fizi. Okay, so I will proceed to our discussion today. So our topic is under mechanical and sound wave, and I will discuss the multiple choice question. And I hope that because of I have sent all of you the question earlier, so I hope that you have tried and we can discuss here. If you have any, if you have the answer or if you want to ask any question, you can write down in the chat box. Okay. So take a look. The first part, I will discuss the concept for each part in this topic. Okay. After that, I will go to few related question. So for the first part of the progressive wave, we have first part of this topic is about the progressive wave. So for the progressive wave, we focus on the progressive wave equation, which is the general equation which is given by y, which is equal to a sine omega t plus minus kx. Okay, so from this general equation of the progressive wave, we will get the a lot of information instead of this equation, which is we will have the amplitude represented by a, omega, which is angular frequency, and to get this angular frequency or hidden information from the frequency angular frequency is we can find the frequency or period. Okay, and then we have the k, which is represented by wave number, which is equal to 2 pi over lambda. And for the positive and negative sign here, if you look at the sign, positive and negative, it is depends on the direction of the propagation of the progressive wave. So if the if the sign is positive, meaning that the wave is moved from right to left. And if the sign is negative here, meaning that the progressive wave propagate from left to the right. Okay. From this equation also, we can plot a graph of y, which is displacement against time t. Okay, so from this graph, the hidden information is instead of the amplitude or maximum displacement, we will get the period, okay, for the progressive wave. And another graph that we can get from this equation is we can plot from this equation is graph y against x. Okay, and the hidden information in this graph is the wavelength of the wave. Okay. Also, we can calculate because of we get a lot of information from the general equation for the progressive wave. We can calculate the wave propagation speed given by v is equal to f lambda. I'm sure that this equation is familiar with you. Am I right? Okay. And also, we can calculate the particle vibrational speed, which is given by v is equal to if speed actually no plus minus. Let's say if you need to calculate the particle vibration velocity, so the equation is plus minus omega z a square minus x square. Or if you have at the certain times, so you also can use the equation v is equal to a omega cos omega t plus minus kx. So this is the overall for the progressive wave that you need to know before you try to answer the question. Okay, so now we will go to the first question that related to the progressive wave. Okay, so I hope that you can try, and those who have tried, you can write down your answer here before I show you the answer. You can write in the chat box. Yeah. So question number 1, a planned progressive wave is represented by the equation of y, which is equal to 20 sine 24 pi t minus 0.5 pi x. Okay, where x and y is in meter and t is in second. What is the wavelength and frequency of the wave? So this is actually the basic information that you can get from the progressive wave equation. Okay, so what you need to do first is because of given to you the progressive wave equation, so you can write down the general equation first and then identify the information from the question. Okay, for example, referring to the equation given, you get the amplitude which is equal to 20 because of the unit is meter, so 20 meter. Angular frequency 24 pi radian per second, and the wave number which is equal to 0.5 pi per meter. Okay, so welcome Mehrunisa and Ahmad Awais. Yeah. Okay, let do the exercise together. Okay, so when we want to, how we want to calculate the wavelength. So have you tried, Marinisa and Awais? So referring to the equation for the wave number, which is 2 pi over lambda, we can calculate the wavelength of the wave. We just substitute the k, which is equal to 0 0.5, referring to the given information. K is 0 0.5 pi. So you will get the wavelength, which is, what is the answer for the wavelength? Have you tried to answer? Very simple, right? 2 divided by 0 0.5. Because of pi, we can cancel. So you will get the wavelength, which is equal to 4 meter. Okay. So if you get the answer earlier, okay, very good, Marinisa. Okay, how about the, so now the answer, if you look at the choice given, the answer is either A or B, right? Okay, now we want to identify the frequency, either 12 or 24. So how we want to calculate the frequency? Of course, we refer to the equation of angular frequency, which is omega equal to 2 pi f. And then we rearrange to find the frequency. You substitute the value for angular frequency, referring to the equation. Angular frequency is equal to 24 pi. So divide by 2 pi, you will get 12. Am I right? 12 hertz for the frequency. So the best answer is A. Okay, actually, the question is just as simple as that. This is the level for C3 for your PSPM later on. This is C3, the types of C3. Even there are two things that you need to calculate, but it is a basic equation that you're supposed to use. Okay, is it clear, right? If you have any question, okay, very good, Awais. Okay, if you have any question, you can write down in the chat box. Okay, for question number 2. So the diagram below represent a sinusoidal progressive wave with the frequency of 50 kilohertz. What is the speed of the wave? Okay, if you look at the question, only one information given in the question, but there is a graph here. So you also will get the information from the graph, which is, okay, F, which is given as 50 kilohertz. So I just change to the 10 power of 3 hertz. And lambda, which is wavelength, is equal to 10 centimeters. So how we identify the wavelength? So if you look at the graph, the wavelength is for the one complete oscillation. So wavelength is actually 10 centimeter. Okay, or if you change to the SI unit, 10 times 10 power negative 2 meter. Why I change to the SI unit? Because if you look at the choices given, it can be in the centimeter or meter per second. So we're not sure which one, okay? So to identify the speed of wave, we use the wave propagation speed, which is equal to F lambda. We just need to substitute. So if you substitute in centimeter, so you will get the answer, which is equal to, directly you get the 50 times 10 power of 4 centimeter per second, right? Okay, so it's look like the answer is there. Am I right? Or if you change earlier, change to the SI unit, you also will get the answer actually. The answer is also there, but please take a look at the unit. So please be careful, because of sometimes you normally change to the SI unit directly. So maybe first time you try, you get 5 times 10 power of 3. But make sure that you identify the unit, because when we do the calculation, the unit is sometimes we write down later. Am I right? So if you make sure that, check. Uh, Given the choices given here, 5 times 10 power of 3, but the unit is centimeter per second. So the best answer is D. Okay? Is it clear? All right. So I hope that you have no problem. If you have any question, you can ask in the chat box. Now we go to the, if I am too fast, you also can tell me. Okay? All right. So we go to question number 3. So for question number 3, okay, very good. Darin Miku, very good. Thank you so much. Okay, the answer is D. The main point is you check the unit. Okay. All right. For question number 3, the figure shows the wave propagation of the progressive wave, which is traveling to the right with a constant speed of 8 meter per second. So what is the wave equation that represent this progressive wave? So this is another way, the progressive wave question, where from the graph you need to write down the equation. Okay, just now, question number 1 and 2 from the question, from the equation, you need to calculate the value, and now you need to write down the equation. So these types of question also can come on. Okay, so you need to know how to do it. Okay, this is not apply for the progressive wave. It is also can be in the standing wave, or maybe in the chapter 9, for example, simple harmonic motion. The types of question is also can be like this. You need to write down the equation, and get the information from the graph. Okay, so thank you, Halwa Sakina, very good. So what you need to do first when you need to write down the wave equation? So the best thing is you write down the general equation for the progressive wave. That's the most important, because of it is actually hidden behind the equation. It is a lot of information. Okay, if you refer to the general equation, so y is equal to a sin omega t. To write down the equation which is represent this progressive wave from this graph, you need to have the value for a, angular frequency omega, and also the k. And you also need to identify positive and negative sign, which sign that you want to use. If you look at the choice, there are positive and also negative. So which one is the correct one? All right. So first we identified the amplitude. So referring from the information given from the question, first the V is equal to 8 meter per second. So directly you get from the question, and the amplitude referring to the graph. This is also the information given in the question, which is 0.4 meter. Okay, and the angular frequency. So because of we want to substitute the angular frequency in this wave equation, so the angular frequency is 2 pi f, or because of we have no value for f. If you look at the question, either in the equation or in the graph, because of this is graph y against x, so there is no value for frequency or period. What we do, we can change frequency to from the v is equal to f lambda, so f is equal to v over lambda, and this one referring to the equation, v is equal to f lambda. Okay, just replace. And then the lambda, how you want to know the wavelength of this progressive wave? So you need to refer to the graph given. Even they give here 0.2, the distance is 0.2, so our wavelength is 0.4. Okay, so this is very important hidden information actually. In the exam, normally they not put directly the wavelength, so you need to identify from the graph. So because of that, we have the value of V and also the wavelength. When you substitute, you will get the angular frequency, which is equal to 40 pi radian per second. Okay, so we have the A and also the angular frequency. Now we want to calculate the K. For the wave number, so how we want to get the K? By referring to the equation for the wave number, right? 2 pi over lambda, and our lambda just now we have identified from the graph, which is 0.4, and if you calculate, you will get the k, which is equal to 5 pi per meter. And when we get all the info, which is a, omega, and k, we substitute in the general equation of the progressive wave. And here I just write down 0.4 sine 40 pi t minus 5 pi x. So why minus? How I identify minus? The plus and minus just now, the sign is showing the direction of motion of the progressive wave, right? So if you refer to the question state that the progressive wave which is traveling to the right, meaning, traveling to the right, meaning that, what does it mean? Very good. So kalau to the right, meaning that it is from left, so the sign is negative, right? Because of that, okay, because of traveling to the right, that's why we choose the negative sign. So the best answer is D, which is y is equal to 0.4 sine 40 pi t minus 5 pi x. Okay, class. Okay, everybody. Oh, positive Awais, you sure? Maybe you can check. Is it positive? Because of moving to the right, meaning that it is from the left, right? So from the left supposed to be negative. Okay? That's the concept of how we identify the positive or negative sign. Okay, it is okay, what is. Later on you check, yeah? Okay. So can we go? No problem. No problem, what is. Okay. So can we go to the next question?
Okay, sorry, Madam Nu. Before you proceed to
Ah,
next question,
okay,
uh,
teacher Sue.
sorry for interrupt, guys. So let's,
No
I'm
problem.
announce for second digit code for our class today. Okay, student. The second digit code for our class today is number 1. Okay, number 1. Okay, Madam Nun, let's we continue our discussion today.
Okay, thank you so much, Teacher Sue. So you need to write down the code so you can claim. Later on, you can claim the credit. Okay, a lot of gift actually for you. All right. So second part of this topic is about the standing wave. Okay. So for the standing wave, actually, what is standing wave? Or how the standing wave produced. So standing wave is actually there are two progressive wave moving in the opposite direction, combine and produce the superposition and produce the standing wave. So the progressive wave, which is represent, let's say for the example, if we have y1 and y2, okay, so when y1 and y2 combine, it will produce the y, which is equal to 2a cos kx sin omega t, which is this equation is represent the equation for the standing wave. Okay, and uh, from this equation, what is the hidden information that you get from this question, from the general equation of the standing wave? So the first part is the amplitude for the standing wave, which is represented by 2a cos kx. So it is depends on the x for the displacement at the y component. Okay, and then this is two types of standing wave. Okay, the main point, the difference between the standing wave is actually the combination of progressive wave, but the profile of this wave is stationary or we not moving. That's why we call it standing wave. So referring to this profile, we can see we have the A, which is represent antinode, and N is node. So this is either one lah, either one our standing wave. And the main point that you need to know for the nodes, okay, represented by nodes, it is occur at point of zero displacement. If you refer to the y component, which is displacement, x component is distance. So at the y component, the displacement is zero, meaning that the node is there. Okay, the position of node is only at the zero displacement. And for the antinode, okay, for the antinode, it is occur at point of maximum displacement. Okay, maximum displacement. That's the antinode. Okay, that's I think that's overall you need to know about the standing wave. Okay, so we go to the question number 4, which is about the standing wave. A sinusoidal wave traveling in a medium, which is represented by the equation of y1, which is equal to 0.4 sine 40 pi t minus 10 pi x. Okay, so this is the progressive wave equation, y1 represent the progressive wave equation. So y and x is in meter, t is in second. So another same wave, y2, moving to the left, combined with y1, produce a stationary wave. So of course you can imagine the y2. So of course the equation for y2 is because of same wave but moving in the opposite direction or moving to the left. So because of inertial, y1 is the sign is negative, meaning that it is moving to the right. So y2 moving to the left. So both of them combine to produce the stationary wave. So this is the equation for y2. Of course, maybe it is just identified. Okay, there's the second progressive wave. And now we need to calculate the amplitude of the stationary wave. So as I told you, the amplitude of the stationary wave is quite different, right, from the progressive wave. If progressive wave, we get directly from the y component, but for the stationary wave, you need to calculate the amplitude. Okay, but if you understand well about the standing wave, actually you can get directly the answer, which is you look at the 0.4, the amplitude for the progressive wave. The amplitude for the stationary wave is double the amplitude of the progressive wave if the both wave is same amplitude. Or if you want to check the calculation either correct or not, first we can write down the equation for the standing wave first, referring to the general equation for the standing wave, okay, which is 2a cos kx sin omega t. So our a is 0.4, referring to the progressive wave, and our our k is 10 pi, so cos kx and sine 40 pi t. Okay, omega is 40 pi. And then we get the general equation, we get the equation that represent the standing wave from these two progressive wave, which is 0.8 cos 10 pi x sine 40 pi t. Okay, and then for the amplitude of the standing wave, generally, as I said, the amplitude is 2a cos kx, right? So 0.8 cos 10 pi x is represent the amplitude of the standing wave, and the condition for the amplitude is the maximum displacement. So cos 10 pi x supposed to be equal to 1 to get the maximum displacement. So when the cos 10 pi x is equal to 1, so the amplitude is 0.8 meter. That's why the answer is 0.8 meter. Okay, the answer is D. So, is it clear? All right. So, I hope that you get the correct answer, because of this question is very direct. You can save a lot of time if you have this type of question. Okay, you can spend your time in the C4 level C4 question. Okay. So, we go to the question number 5. So, question number 5. Okay, thank you for the response, Awais. Question number 5. A stationary wave is given as y, which is equal to 18 cos 1 over 4 pi x sine 2 over 5 pi t. So this is our stationary wave equation or standing wave equation, where x and y is in meter and t is in second. So you need to find the position of the second node and the third antinode. Okay, this is C4 level. Okay, this types. So you need to alert. You need to find two things in this question. Okay. Can anybody guess the answer? Or if you have tried, can you write down your answer in the chat box? Anybody want to try? Yes, Nashlan. How are you? Filza, thank you so much. Okay, can you give your answer in the chat box? Thank you, Madam Cikgu Faiza. Cikgu Faiza is also with us. Okay, so let's take a look. Let's find the position of second nodes and the third antinode. Okay, so first, to identify the nodes or antinodes, we refer to the amplitude. Okay, because of our main reference is the amplitude, which is equal to 18 cos 1 over 4 pi x. Okay, this is the amplitude of the stationary wave. Okay, for the position of nodes, okay, as I told you earlier, to get the nodes occur when the displacement is equal to 0. So y at the y component, displacement at the y-axis is equal to 0. So what happen if y is equal to 0? So our amplitude or cos 1 over 4 pi x is equal to 0. Okay. And then if you find you will get that shift cos 0 is equal to pi over 2, 3 pi over 2, and the rest, because we want to find the second node only. So it's supposed to be after the next node, the third node is 5 pi over 2, 7 pi over 2, and so on. Am I right? So and then from here you can calculate the x. So pi over 2 times with 4 over pi, 4 over 2 is equal to 2. So you will get the x, or the position of node, the first position at x is equal to 2 meter, and the second position of node is 6 meter. Okay, so if you look at that, the choices given, you have to choose. Normally, there are two close answer. Okay, so here now, when you calculate the notes, you know the note is 6 meter. So the answer either B or C. Now we want to identify the third antinote. So either 4 or 8 meter. Okay, look, if you think logically, okay, because of the third antinote is supposed to be, I just share with you the smart way of thinking to shorten your time answering the objective question, yeah. Third note, of course, third antinote, of course, after the second notes. Am I right? So you can guess because of second note is 6 meter. So what is the next antinote? Actually, you can guess, but if you're not sure, if you don't want to guess, uh, but I think you sure, you sure you can guess the choice. You can save a lot of time. But if you're not sure, but it is okay. I will show you. So for the antinote, as I said, antinote occur when the displacement is maximum, meaning that to get the maximum displacement, cos 1 over 4 pi x supposed to be equal to 1. Then the amplitude, then it is equal to amplitude or the maximum displacement. Okay, when the cos 1 over 4 pi x is equal to 1, so you find the shift cos 1. Okay, so you will get the value which is equal to the first position is 0, second is pi, and the third one is 2 pi. And when you calculate the x, the position of the antinote, you will get that the x is equal to 0, 0 meter for the first position, second position is 4 meter. Okay, and the third position is 8 meter. Because of that, the best answer is C. Okay, so logically, as I told you earlier just now, why I say you can answer it quickly, because of if you can identify the notes which is equal to 6 meter, of course the third note is greater than the second note. Okay, the third antinote, because of the third antinote is after the second note, so it's cannot be 4 meter lah. That's the secret, Cik Wah. Okay, so the answer is C. Okay, now we go to the question number 6. No. Before question number 6, that's the question from the standing wave. Now we look at the application of the standing wave. So for
Okay,
the
sorry,
application of
sorry for interrupt,
ah,
Madam Min.
okay,
Okay,
teacher Sue.
before we continue our discussion, let's we take a break for advertisement first.
Okay.
Okay, before we take a break for the advertisement, let's teacher announce for third digit code for our class today. Okay, please take note, and the code is 1. Okay, the code is number 1. Okay, so now we take a break for advertisement. See you after this advertisement, and stay tuned.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay.
Okay,
So we
Madam, can we continue our discussion?
Okay, thank you so much, Teacher Sue. Okay, now we go to the application of standing wave. So for the application of, just now we applied the equation for the standing wave. And for the application of standing wave, we refer to the three part. Okay, the first part is in the stretch string. Okay, so in the stretch string, we have the speed, the equation for speed of wave in the string, which is V is equal to T over mu. And mu is referred to the mass per unit length, okay, of the string. So this table, I just show the table represent the stretch string for the standing wave in the stretch string. And for the stretch string, we call it all harmonic because of for the fundamental tone, for example, it is a first harmonic. For the first overtone, it is represented by we call it second harmonic, meaning that the first harmonic and the second harmonic. And we also have the third harmonic, fourth, fifth harmonic. So we call it all harmonic present in the a stretch string. Okay, instead of the v, the speed of wave in the string, and also we can calculate the frequency h each overtone. Okay, and then the second and third part is in the air column. So in the air column there are two, which is we call it open pipe and closed end pipe. So open pipe is actually both pipe is open at both end. The pipe is open at both end. And for the closed end pipe, one end is closed and another end is open. So to differentiate between these two, okay, I show you in this table. So actually for the string just now, the condition that you need to take note is at the end of the string, at the tie part, it is produce the note. Both end is note. Okay, for the open pipe, if you look at the condition for the open pipe, both end, because of both is open, so both end produce the anti-note for the standing wave. Okay, and then for the close open pipe also we call it all harmonic. Okay, all harmonic present in the open pipe because of we have the first harmonic and then second harmonic, third harmonic, and so on. But for the close end pipe, okay, if you refer to this table, so the condition for the closed end pipe, the closed end, one end is closed. So at the closed end, it is represented by the note, and at the open end is anti-note. Okay, because of that, if you look at the this is the fundamental note. Okay, and then the first overtone represented by the third harmonic. The first one is the fundamental note is first harmonic, but the second or the first overtone is third harmonic. Why third harmonic? Because of there are three harmonic shape inside this closed end pipe. And for the fifth harmonic, there are fifth harmonic shape. So the first fundamental note is the harmonic shape, the first harmonic shape. That's why we call the closed end pipe ni is odd harmonic. Okay, so you need to differentiate these three types of standing wave, application of the standing wave. Now we will take a look at the related question. So question number one and question number 6, a wire of mass 45 gram. So as usual, actually, when I read the question at the same time, when you read the question at the same time, my suggestion is you list all the information given from the question so that when you substitute, you will do no mistake. Okay, you will substitute the correct value. For example, when you read the question, 45 gram, you change to the kilogram, to the SI unit. So a wire of mass 45 gram is stretched between the 2 points uh, 150 centimeter apart. So because of this is a string, so 150 centimeter is represent the length of the string or the wire. Okay, with tensional force of 86 Newton. So T is 86 Newton here. When the wire is plugged, standing wave are formed in the wire. Okay, what is the fundamental frequency and the second overtone frequency of the wire? So this is the C4 types question. Yeah? So you need to calculate, you need to do calculation, and you need to do a few analysis to get the answer. Okay, for the first one, which is the hidden information from the given information. Okay, because of if you refer to the given information, there are mass and also the length of the wire. So the hidden information you can get is the mu, which is the mass per unit length. So you can calculate first, which is when you calculate, you will get the mu, the mass per unit length of this wire is 0.03 kilogram per meter. Okay, that's the hidden information. So either you use it or not in the calculation, it is okay. So you just follow because of it is a very related information. Okay, and it will help you actually to answer the question. So to get the fundamental frequency, which is F naught, so I just sketch. If you can imagine, no need for you to sketch, but I just sketch to show you the fundamental frequency in the wire or in the string. Okay, and then if you refer if the length of wire L, so we'll get the relationship for the wavelength. Am I right? L relate to the wavelength. So in this case, because of this is the first harmonic shape, which is half of the wavelength, so we can get the wavelength which is equal to 2L. Okay, wavelength is equal to 2L. That's the first analysis that you do from the fundamental frequency. Okay, now if you want to calculate the fundamental frequency, we refer to the equation, the second equation. Actually, this is the third equation, right? The first equation is the mass per unit length. The second equation is you identify the wavelength of the standing wave in the wire. And now you want to calculate the fundamental frequency referring to the equation of V over lambda. And then our V just now is the speed of wave in the string, which is 30 over mu, right? We just replace 30 over mu. And the wavelength here we have identified which is 2L. So you just need to substitute the value. L is 1.5. Okay, refer to the given information. T is 86 and mu you have calculated earlier. See, the hidden information is used. You need to use it in the equation 0.03. So you will get the F naught, which is equal to, okay, anybody knows the value for F naught? Can you calculate? Or you have calculated and you can check your answer. So you will get the F naught, which is equal to 17.85 Hertz. Am I right? Okay, if you look at the choice given, you cannot answer yet because of there are two nearest answer, either A or B. Okay, because of both is 17.85 Hertz. Now, we need to calculate the second overtone frequency. Okay, so take a look at the calculation for the second overtone frequency. So initially, we have the F naught, which is 17.85 Hertz. For the second overtone frequency, can you imagine the harmonic shape of the second overtone frequency? So for the second overtone, which is the third harmonic, because of fundamental frequency is the first harmonic, first overtone is the second harmonic, and the second overtone is the third harmonic. So there are third harmonic shape in the wire. So this is the diagram for you to understand why I said it is the third harmonic for the second overtone frequency. Okay, and because of that, we know for the second overtone frequency, it is equal to 3 times the fundamental frequency because of the third harmonic, right? So 3 times F naught. So our F naught is 17.85. When you calculate, you will get the second overtone frequency, which is equal to 53.55 Hertz. So the best answer is B. Okay? Everybody get the correct answer, right? Okay, actually the calculation, if you substitute correctly with the correct SI unit and you check everything, you use the correct equation. Equation is no problem because of you just need to choose the correct equation. But for the relationship like F2 is equal to 3 F naught, no need to remember. You just need to understand the basic fundamental mode ataupun or fundamental node. Okay. All right, now we go to the question number 6. Okay, thank you, Miza Fika. Okay, I hope that you understand, you're clear with the solution. All right, so we go to the question number 7. So the fifth harmonic frequency
Sorry,
produced...
Madam No.
Yes, Teacher
Interrupt
Sue.
again. So before we proceed to question number 7, let's we announce the 4-digit code today. Okay, so
Okay.
the 4-digit code for our class today is number CN. Take note, students. Okay, so now Madam Nu can continue our discussion today.
Okay, so for question number 7, the fifth harmonic frequency produced in the closed at one end pipe is found to be 232 Hertz. What is the fundamental frequency of this vibration? Okay, so fifth harmonic frequency for in a closed at one end pipe. So as I told you just now, closed at one end pipe is the odd harmonic, right? So from the question, we get that for the fifth harmonic, it is represent F2, the second overtone. Okay, so is it correct? How you want to identify? How do you know that the fifth harmonic frequency in the closed at one end pipe is a second overtone frequency? So let's take a look at the shape of the harmonic shape. Okay, because of the condition for the closed end pipe, the note at the end close, at the closed end is note, at the open end is anti-note. So there are 5 harmonic shape. So node and antinode. The first node and antinode is the first harmonic shape. So to produce the fifth harmonic shape, okay, which is to produce the antinode at the open end. So this is the shape of the harmonic. Okay, that's why we identified that F2 is equal to the given info 232 Hz is represent the second overtone frequency. And if you understand the part very easy. F2 is equal to 5 F note. Because of fifth, there are 5 harmonic shape in the close at one end pipe. Okay, and then because of our F2 given is 232 Hz, you substitute and you need to divide by 5, you will get the fundamental frequency, which is equal to 46.4 Hz. This is quite direct actually. But to get this answer, I'm sure that you need to think a lot, and sometimes it's quite confusing, right? Because we have two types of pipe, closed pipe and open pipe. So you need to identify the harmonic shape, and you also need to identify the overtone. And please remember, for the overtone, just to remind you, actually the basic is fundamental note. Fundamental is the basic. Okay, fundamental is basic, right? And then for the after the basic is the first overtone. Okay, so first overtone is represent the third harmonic for the closed end pipe. Okay, and the second overtone is the fifth harmonic shape. Okay, so please do differentiate between the closed end pipe and open pipe. Okay. This is normally lah student will confuse. Okay. Now we go to the question number 8. For question number 8, the answer is A lah just now. Okay, because of 46. Okay, actually the answer is 46.4 Hertz. If you look at the choice, there is no exact answer, right? 46.4. So you can choose nearest answer. Okay, which is A. Now we go to the question number 8. Before question number 8, the question number 8 is related to the sound intensity in this topic. So sound intensity is the third subtopic in the mechanical and sound wave. So the definition of the sound intensity is the rate of sound energy flow across unit area perpendicular to the direction of the sound propagation. So the rate of sound energy flow is represent the power. So P is the sound power. A is the area perpendicular to the direction of the sound propagation. Normally for the sound wave, the sound move in the spherical shape. Okay, so the A is represent the area of the spherical shape. Okay, and the dependency of the intensity to the amplitude, we have the relationship of intensity is directly proportional to the amplitude square. So in this part, I just want to remind you, don't confuse with this A. So for the definition of intensity or general equation for the intensity, P over A is the area, but the dependency of intensity, it is depends on the amplitude of the sound wave. Okay, amplitude square of the sound wave. And for the distance from a point source, so it is inversely proportional. The square of the distance between the point source, meaning that far away from the sound source, of course you will hear less, right, compared to you near to the sound source. Okay, so this is the relationship. So from this few concept in the sound intensity, take a look at question number 8. We will apply the equation. Yeah? A point source emits sound with a power output of 100 watt. What is the intensity at the distance of 10 meter from the sound source? So you can see that the R, the given information is the power, which is 100 watt, and the R is 10 meter. So to calculate the intensity, or the thing that I want you to understand is the shape, the area. The area represented by the sound wave is the area of the sphere, because of sound wave is at the center of the sphere, so it will move to all direction. Okay, because of that, when you want to calculate the intensity, you need to calculate the area first, because of given only the distance. So area for the sphere is 4 pi r square. So this part, please be careful. It is a lot of area, a lot of equation for the area. Sometimes we refer to the cross-section area. So in this part, it is referred to the area of the sphere, which is equal to 4 pi r square. So you calculate and then you substitute. You can substitute in the equation and you will get the intensity. So anybody? Okay, hi Andrew. Do you get the answer for the intensity? So hi Sophie. So what is the answer for the question number 8? For the intensity, it is equal to, if you calculate, you will get the answer which is equal to 7.96. Okay, all is 7.96, but 10 power of negative 2 watt per meter cube per meter square. So the best answer is B. Okay, in this case, please be careful with the power of either negative 2 or negative 3. Make sure that you look at your calculator clearly. Sometimes too, you have done the calculation correctly, but your eye cannot see the correct answer. That's also the problems. Because of this type of question, all the answers is correct, 7.96. But which one? 10 power of negative 3, negative 2, or negative 1? So please take note about that. Okay? And then for question number 8, so an underwater explosion is detected 100 meter away, where the intensity is recorded to be 1 gigawatt per meter square. After 1 second later, the sound wave is recorded 1.5 kilometer away from the ground. What will be its intensity at that distance? Okay, what is the intensity at 1.5 kilometer? So to calculate, if you refer to the given information, we have the R1, I1, and also R2. The distance is 1.5 kilometer. So we want to calculate the I2. So in this case, we know the relationship of the intensity with the distance, which is inversely proportional to the square of the distance between the point source. And we can use the mathematic relationship, which is because of I is inversely proportional to the R. So I2 over I1 is equal to R1 square over R2 square. Okay. And then we just substitute the value for I1. Okay, in this case, luckily, all the information given in the SI unit, except for the kilometer, you just change to the SI 10 power of 3. And then gig, you need to change. Giga is 10 power of 9, right? So when you calculate, you will get the I2, which is equal to 4.4 times 10 power of 6 watt per meter square. Or because of 10 power of 6 is mega, so we also can get the answer because it depends on the answers given to you, choices given to you. So 4.4 megawatt per meter square. So the best answer is C. Okay, so 6.7 is actually, you also can get the answer for 6.7 if you not square the distance R, if I'm not mistaken. Okay, so is it clear? Clear everyone, right? Okay. Now we go to the question. Before we go to the question number 10 and 11, there are another two question. So the last part of the mechanical and sound wave topic is the Doppler effect. So just for the revision, the general equation for the Doppler effect is, or the Doppler effect is, the purpose of Doppler effect we use is to identify the frequency heard by the observer, which is F naught is represent the frequency heard by the observer, uh, because of the relative motion between the observer and the sound source. Okay, Fs is the source, frequency of the source. So to identify our equation, either if you look at the general equation, we have the positive and negative sign here. So you need to identify correctly because of the equation is there. You just need to identify the correct. Either you need to use the plus or minus. So how you want to identify? Either it is plus or minus. So we just need to compare the direction of speed of sound. So V is represent the speed of sound. V naught is the speed of the observer, and Vs is the speed of the sound. And for the speed of for our level, we just specify only one stationary, or only one moving, either observer or source only. So because of that, we can conclude when we compare the direction of V, the speed of sound is V. You can choose like this. When we compare the direction of V, speed of sound, with the direction of source, if both direction is in the opposite direction or not same direction, so, and also V, speed of sound, with the speed of the observer, if the direction is not equal or in the opposite direction, so we will use the sign plus. Okay, and of course, if the direction of the speed of sound equal to the direction of the speed of a source and also the observer, so we will choose the sign here, negative sign. Okay, is it clear? Is it clear? Clear, right? Okay, please take note. This is very important tips. Okay. And now take a look at the question. So for question number 10, a car approached a stationary police car. Okay, you need to read the question carefully, and from the situation given, you need to identify who is the source and who is the observer. So in this case, yeah, a car approached a stationary police car at 36 meter per second. So if you want to list the information, so our source, our observer, because of a car approached a stationary police car at 36 meter per second, meaning that the speed of the observer is 36. The frequency of the siren produced from the police car is 500 hertz. So police car now stationary and it is the source. So Fs is equal to 500 hertz. The question want you to calculate what is the frequency heard by an observer in the moving car as he approached the police car. Maknanya, meaning that it is clear show that the car is the observer. The person inside the car is the observer and the police car is the source. Okay. And we need to use the speed of sound. Actually, the range of the speed of sound between 330 to 345 meter per second. So you can use the speed of sound which is 343 meter per second. All right. Now, can you identify? Okay, if you want to look at the diagram given, so the car I just showed here, we note is the observer. The car approached the stationary police car, produced the sound with the frequency of 500 hertz, and of course, how to identify the direction of the speed of sound. So speed of sound is always toward the observer. So our observer is now is the person in the car. Okay, so the direction is toward the observer. Okay, this is the situation, and we want to calculate the frequency heard by this observer inside the car. All right. So you can see now you can sketch when you answer, even it is objective question, because of when you want to identify the equation from the Doppler effect, general equation for the Doppler effect. Yes, very good, Andrew. Source of sound is siren. Okay, very good. You are right. Okay. So for the frequency heard by the observer, the equation that we identify is, okay, YV plus V naught, because of we compare between the speed of sound with the observer, speed of the observer, and you look at the direction V naught and V, it is in the opposite direction. So if opposite direction, we need to use the sign plus. And because of Vs is 0 stationary, so below this is only V times with the Fs. Now you can substitute the value given, okay, where V is 343, V naught is 36, and Fs is 500. So you will get the answer for the frequency heard by the observer is 552.5 Hertz. So the answer is, for the question number 10, the answer is C, 552.5 Hertz. Okay, so for the Doppler effect, the main point is you can identify first. Before you identify the equation, you need to understand the situation. You need to compare the direction of the observer with the speed of sound and also the source. Okay, now take a look at the last question for today's class, which is question 11. So actually this is the same question. The situation is same, but if you look at the car moving with the car, which is the observer moving with 36 meter per second, passes a stationary police car. Now this observer in the car passes the police car where the police car is still stationary. Okay, and then the siren is still produce the frequency of 500 hertz. What is the change in the frequency heard by the observer? Remember, this is the change in frequency. Please read the question carefully. And also, I suggest you, if you get the question, please highlight what you want to calculate. Please highlight. So sometimes the question, if you calculate first, the answer is there. You directly choose without take a look at the final question, actually what the question want. So in this case, the question want you to calculate the change in frequency heard by an observer in the moving car as he passes the police car. Change meaning that initially the observer approaching the stationary police car, and then passes the police car. So you need to find the change in frequency heard by the observer. Okay, because of that, the diagram, because I want to find this here, I highlight. You need to calculate the change of frequency. So before you find the change of frequency, of course you need to calculate the frequency heard by the observer when the observer pass the police car, right? So there are two things that you need to calculate. So these types of question is C4 level, because of you need to do analysis first. You need to identify the first info. Okay, and then for the speed of sound, because of the observer is passes the police car or moving away from the source, so but the speed of sound is always directed to the observer. So in this case, V, the speed of sound is directed to the observer. Okay, now we identified the Doppler effect equation that we're supposed to use to find the frequency heard by the observer when when he passes the police car. So here we use the negative sign. Why negative? Because of if you compare the speed of sound with the direction of the observer, so the direction of speed is in the same direction, right? That's why we use the sign negative. Okay, and then the source is still stationary, so below the equation is only V. We substitute the value and you will get the answer for the frequency heard by the observer is 447.5 hertz. So if you're careless, if you are excited to get that answer, and if you look at the choice given, the value for 447.5 is here. So but this is only the frequency heard by the observer. Actually, the question want you to calculate the change in the frequency. So for the change in frequency, you need to refer to the previous question, which is when the observer approach the police car or moving towards the police car, the frequency heard is 552.5, and when the observer passes the police car, the frequency is 447.5. So you need to find the difference in this frequency. So the best answer is, or the real answer is actually A. Very good, Andrew. The answer is 105.0 hertz. If you look at the question, it's look like very simple, right? But you need to read the question carefully. The main point is because of the choice. Sometimes the choice is there. Anything that you calculate actually given in the choice. So make sure that your work, your unit, what you need to do read the question carefully and identify what the question want. That's the most important. Okay, so I think that's it for our class today. I hope that you can recall back what you have learned, and I hope that we can continue discuss the next chapter, which is chapter 11, 12, and 13 until before your PSPM. I hope that you also do the revision, do the preparation for your PSPM. Okay, so that's it for today's class. Thank you very much to all students and teachers support this class today. So I give back to our moderator, Teacher Sue. Thank you so much. Okay, Teacher Sue.
Okay, thanks. Okay, we got grace. We have reached the end of today's seasons. Thank you, Medano, and congratulations to those who are able to follow our last class from the beginning, and click the subscribe button and activate the icon bell so that you the like button. Once is type done on the chat box or as the last note for the class. So let's announce for that code for class today. So the last digit code for class today is students. Okay. The certificate link the box. Please share today's for social media. Please take note while the certificate link will end half an hour. Make sure to use the EDD email, my guru email,
Okay, so looks like our moderator is got technical problem, so I will replace her. So I think the last digit code announced already, right? But I just repeat it, maybe not clear just now, right? Okay, so the last digit code is number 6. Okay, number 6. Okay, the last digit code is number 6. Okay, so all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, so please do so. Make sure it turns to grey color, okay, not the red color. Okay, so and also activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, so click like and share to your friends on your social media. Okay, spread and share the goodness. Okay, so once completed, type done on the chat box before the certificate link is given. Okay, so I'm going to give the certificate link in the chat box. Okay, given already. I think not yet. Okay, I give the certificate link on the copy paste. Okay. Okay, so please take note, the link will end half an hour after this live. So make sure to use the EDD email only to log in, and incorrect email use will not be entertained. So if you haven't got one, please apply. So the link to apply the EDD email is also will be given in the chat box. So the link for the EDD email for you to apply. Okay, so I will paste there in the chat box. Okay, then for the link credit, okay, okay, for the link credit also I will paste for you to claim the credit. Okay, I will paste in the comment. Okay, so please take note, the link will end only half an hour after this live. So make sure to use the EDD email only to log in, or more, email more. Okay, two emails can be used to apply the to claim the credit. So if you wish to get more information on the online classes, go to the www.academyyoutuber.com. So to those who haven't joined EDD Junior Telegram, so please do so. And once again, I would like to thank all of the students for joining today. So remember that the more class you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. Okay, so I think that's all for now, and see you in another session. Ingat hashtag, okay, bermula percuma, selamanya percuma. Okay, Assalamualaikum. Stay safe till we meet again next week, same day, same time, on Saturday at 5 p.m. Okay, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.